Hello everyone, welcome to IIT and GATE classes. This is lecture 3 on compiler design. Okay, and in the previous lecture, we have studied types of parsers, and I have already told you that this chart is very important. Many GATE questions have been asked from this chart only, so you have to by heart this chart. And anyway, don't worry about it. If you are thinking that this chart is very big and we are not able to remember it, don't worry. When we will jump to each and every parser now, then you will get the entire idea about all this chart. Okay, yeah. So let's start our today's lecture. So in today's class, we are going to study types of grammars. Okay, and whenever I say grammar in compiler design, you have to consider that as context-free grammar only. That means type 2 grammars we are going to study in entire compiler design subject. Okay. So grammars are of two types, ambiguous and unambiguous. Okay, ambiguous is just like this. S implies A or capital A and A goes to small a. Unambiguous is S implies yes or A. Why this grammar is ambiguous? Because I have already told you in TOC subject. Okay, if you have not watched my TOC lectures, then my kind suggestion is please watch these lectures so that you get idea about the kind of concepts which we are going to study in compiler design. Actually, in TOC we have studied FA, NFA, DFA, and so on. That means acceptors for type 3 languages. These were applied in lexical analysis, that is the first phase of compiler design. And we have studied context-free grammars, that is in chapter 3 of TOC. Are you able to remember it? So in chapter 3 was context-free grammars and PDA, okay, CFLs and PDA. So that chapter will be used in your second phase of compiler, that is syntax analysis, okay, or syntax analyzer or parser. Okay, so you have to be fluent in context. What are context-free grammars? What is ambiguous grammar? What are unambiguous grammars, and so on? You have to be fluent in that. If you are not able, to follow me, or if you think that I am running a bit on faster pace, then it's my kind suggestion. Please watch my TOC playlist. Okay, you will get the idea about all these things. Okay. Anyway, let's jump to our topic. So context-free grammars are of two types: ambiguous and unambiguous. I have already told you in POC what are ambiguous and what are unambiguous grammars, but let me just revise you. Why this grammar is ambiguous? Because to generate the string A, we have two parse tree. One parse tree and another parse tree is S goes to A goes to A. Okay. So since to generate a string A, okay, see, to generate the string A, we have two parse tree, and this grammar is ambiguous. And why this is unambiguous? You can generate any string. There will be only one parse tree. To generate single A, you will be having only one parse tree. To generate double A, S goes to AS and S goes to A. To generate triple A, S goes to AS, then AS, and then A, and so on. Okay, to generate single A, there is only one parse tree. To generate double A, only one parse tree. To generate triple A, only one parse tree, and so on. So for each and every string, we have only one parse tree. Okay, that means what this grammar is unambiguous. And why this grammar is ambiguous? Because we are able to find one string for which we have two or more parse trees. Okay, so let me revise the definition of ambiguous grammar. A grammar is said to be ambiguous if and only if there exists at least one string which is generated by the grammar, and we are able to make two or more parse trees, or two or more LMDs, or two or more RMDs. Okay, I have just given you the definition of ambiguous grammar. Please note it down carefully. Pause the video, note it down carefully. If you are not able to follow, please rewind the video and listen my definition again. Okay, and I'm not going to repeat it because I've already told you all these things in TOC subject. It was just a revision for you. Okay, and when we say grammar is unambiguous, a grammar is said to be unambiguous if and only for each and every string which is generated by the grammar, there exists exactly one parse tree. Okay, yeah. So I think I have made the point clear. If you still not able to follow, I am saying again and again, watch my TOC playlist. You will get the idea about what are ambiguous and what are unambiguous grammars. Okay. Now let's move to the next slide. See, parser cannot parse ambiguous grammars. Okay, this is very important point. Please make some stars on it. This is very important point, and this has been asked many times in GATE as well as UGC-NET and other competitive exams. Parser cannot parse ambiguous grammars. Okay, but we have only one exception, that is operator precedence parser, which can parse few but not all ambiguous grammars. This is very important. Okay, so once again I am reading this out for you. Parser cannot parse ambiguous grammars. Okay, so if we have any parser, then it cannot parse ambiguous grammars, but only one exception, that is operator precedence parser, which can parse few but not all, ambiguous grammars. Okay, you have to by heart this point. And anyway, we are going to prove this point after few slides also. Okay, so operator precedence parser, it can parse few but not all ambiguous grammars. Okay, but if you talk about generally, if you say parser cannot parse ambiguous grammars. Why it cannot parse ambiguous grammars? That question I have answered in the next slide. Okay, please note it down, and I'm jumping to the next slide now. Yeah. So now that directly our question is why ambiguity is a problem, or you can say why parsers cannot parse ambiguous grammars. So let me take one example of ambiguous grammar. This is our grammar, and our string W is 2 plus 3 star 4. So E implies E plus E or E star E or ID. So expression can be expression plus expression, expression multiply expression, or ID. ID means identifier, or you can take any constant here. Okay. So 2 plus 3 star 4. Let me make a parse tree. E implies E plus E. E goes to E plus E. Okay, and this E goes to E star E, and this E goes to 2. This E goes to, okay, let me write properly, otherwise you will get confused. This E goes to ID, this goes to ID, and this goes to ID. Now this ID is 2, this ID is 3, and this ID is 4. Now see here, 2 plus 3 star 4 we have generated. Another way of generation can be E goes to E star E. By the way, in TOC also I have discussed the same grammar. Okay, you can watch my TOC playlist also. Now, while explaining ambiguity problem, we have studied this thing. Okay, so E star E, then we will say E goes to E plus E. This goes to ID, ID, and ID. This ID can be this 2, this is 3, and this is 4. Yes, now you can check it out. We have made 2 parse tree to generate this string, hence the grammar is ambiguous. Now the problem is why parser cannot parse this, because parser cannot decide whether this parse tree is correct or this parse tree is correct. You may argue that, sir, it hardly matters, we can take any one of the parse tree. No, if we take if we take this parse tree, then our answer will be different. Like for example, I will say to solve this expression, you will say you have to solve this expression as well as this expression, and then you will add these two expressions to get the value of this expression. Now this expression is already solved as 2. You will solve this expression. To solve this expression, you have to solve this expression as well as this expression. You will get, and you will multiply these two expressions to get this expression. So 3 multiplied by 4, that is 12. So here you will get answer as 12, and here you will get 2. 2 plus 12, that is 14. You are getting answer as 14. Now similar idea here. To solve this expression, you have to solve this expression as well as this expression. This expression is already solved, and you have got the answer 4. Now to solve this expression, you have to solve this as well as this, and you have to add them. Okay, so finally you will say what? This is 2 and this is 3. 2 plus 3, that is 5. So 5 into 4, that is 20. Okay, see again, see what I have done. You have to see, to solve this expression, you have to solve this expression, and you have to multiply them. This expression is already solved, you have got the answer 4. To solve this expression, you have to solve this expression, and you have to add them. To solve this expression, you have already got 2. Solve this expression, you have already got 3. 2 plus 3 is what? 5. So 5 multiplied by 4, that is 20. 20 is the answer. So what should be the answer? 14 or 20? Which is correct, which is wrong? Compiler cannot, parser cannot decide it. That is the main problem. Okay? So that's why we say ambiguity is a problem. So directly and indirectly, what I want to say, if for a string, parser, if for a string, okay, we are getting 2 or more parse trees, then parser will not be able to decide which parse tree is correct and which parse tree is wrong. And according to the parse tree, we may get different answers. So that is a very big problem. I hope I have made the point clear to all of you. Okay, so that's why ambiguity is a problem. Okay, please note it down carefully, and I am jumping to the next slide now. Yeah. Okay. So everybody has noted down. I'm jumping to the next slide now. Yeah. So next is, see, we have already told you that ambiguity is a problem. Now the question arises: can we have an algorithm which can take input. Okay, see, let me show you here. Can we have an algorithm which can take input as a context-free grammar, and it can say that the given grammar is ambiguous or if this grammar is unambiguous? Can we have any algorithm? No. That means this is an undecidable problem, and in TOC we have already proven that this is undecidable problem. When can we say problem is undecidable? When no one in this world, please try to note it down carefully, no one in this world will ever be able to write algorithm for it. And this has been proven. This is a very strong statement. We are not saying that today, tomorrow, somebody is not able to write and so on. We are saying that no one in this world will ever be able to write algorithm, will ever be able to write algorithm for this problem or for it. Okay. So this is a very strong statement, and obviously it has been formally proven also. Okay, that nobody will be able, nobody in this universe will ever be able to write algorithm to solve this problem. Okay. Hence, we call it as undecidable problem. Checking the given context-free grammar is ambiguous or not is an undecidable problem, and we have already studied that in TOC also. Okay. Now the next question is, can we have an algorithm? See, by hook or by crook, we come to know that the given grammar is ambiguous. We come to know that we have a given ambiguous context-free grammar. By some common sense or by doing something, we have got the idea that the given grammar is ambiguous. Now, can we have an algorithm which can convert this ambiguous context-free grammar to unambiguous context-free grammar? Can we have an algorithm for it? No. Again, it is undecidable problem. Okay, again, it is an undecidable problem, and this has been properly proven also. So I have written this point that converting given an ambiguous context-free grammar to unambiguous context-free grammar is an undecidable problem. Okay, so directly indirectly we are stuck now. See, we have a context-free grammar. Okay, we have a context-free grammar. We are not able to say, or we cannot say algorithmically. That means by algorithm we cannot say that it is unambiguous or it is ambiguous. And if we know that it is ambiguous, then by hook or by crook we come to know that this is ambiguous. Then we are not able to convert it into unambiguous grammar. Why our main concentration is on unambiguous grammars? Because they can be passed by parsers. Ambiguous grammars cannot be passed by parsers. Okay. Only one exception is operator precedence parser, which can pass few but not all ambiguous grammars. So that's why our main concentration is on ambiguous grammar. But the problem is we are not able to find the given context-free grammar is unambiguous or ambiguous. That is the main problem. So we are directly stuck here. Now the question arises. Actually, see, we do not have any algorithm, but we have some disambiguity rules. That means if we are having some ambiguous grammar, then we can convert it into unambiguous grammar by some rules and regulations, which we are going to study in the next slide. See here carefully. We have some disambiguity rules. First, see, is this grammar ambiguous? Yes, of course it is ambiguous. Why? See, we will say, take a string W as, let me use a different color. Okay, take a string W as ID plus ID plus ID. For this string, see carefully, E implies E plus E, and then E plus E, and then ID, ID, ID. Another parse tree is E plus E, E plus E, ID, ID, and ID. You may argue that, sir, how you have identified that this is ambiguous and you have done on a very faster manner. How you have done it? See, because because in my mind I am having disambiguity rules. That's why I am able to give immediately. Okay, I have immediately given you a string and I'm saying that see, we have got the two fastest because disambiguity rules are in my mind. So let me show you something. Why this grammar is ambiguous? See here carefully. When we say E implies E plus E, then we have opened two branches. Okay, now we can see if I need again ID plus ID. So, or you may say E plus E, then this E can be expanded as E plus E, or this E can be also expanded as E plus E. That is the main problem. That's why we have got two path trees, because we have two paths. Two paths, obviously, two path trees. So I hope I have made the point clear. That's why this is ambiguous grammar. Okay, because we have two paths. Now, how will you convert it into unambiguous? Obviously, you just stop one path. So directly, indirectly, what I want to say is, please note it down carefully. Okay, yeah. So now directly, indirectly, what I want to say is, you just stop one path. That means you say E plus ID, or you say ID plus E. Now see here carefully, we have only one path, and here also we have only one path. So this path has been stopped, and again here also this path has been stopped, because we have ID here. ID cannot be expanded. So directly, indirectly, we have stopped one path. Okay, so see here, we were having two paths, and now here we have stopped the one path. So I hope I have made the point clear to all of you. Okay, now see. Okay, now see one more point. See one more point. Okay, see here carefully. If I say like this, see, E implies, okay, or let me write it here. E implies E plus ID or ID. And for this, we will say E implies E plus, sorry, ID plus E, ID plus E or ID. Now our string was ID plus ID plus ID. According to this grammar, if we expand, what we will get? E implies E plus ID. And now see, there is no choice here. We have to expand here only E plus ID, and you will say E to ID. So you have got ID plus ID plus ID. And if you expand this grammar, at string is ID plus ID plus ID, then what you will get? ID plus E, ID plus E, and ID. You have got ID plus ID plus ID, and only one way. I am guaranteeing it. We will get only one way. Because we have stopped one path. We have only one path. So if we are having only one path, then we have only one choice. We have to expand that path only. So we have got this way, and here we have got this way. Now see carefully. We have in TOC we have already studied. See, what is this? E and E here, left recursion. What is this? Right recursion. E and E matching here, right recursion, and this is left recursion. Okay, so if we have left recursion, then see carefully, ID plus ID plus ID. So to solve this E, you have to solve this E. To solve this E, you have to solve this. So finally, what will you do? ID plus ID will be solved first, and then you will add it with the ID. So directly, indirectly, what I am saying is, this is expanding like this: ID plus ID plus ID, like this. So directly, indirectly, what I am going to say is, plus is becoming left associated. That means left plus is solved first. Plus is becoming left associated. So left recursion means left associated. And see, we have written like this only: left recursion, left associated. Okay, yeah. And here E implies ID plus ID. So I will say E goes to ID plus E. And so to solve this E, you have to solve this E. To solve this E, you have to solve this E. So ID plus E. So ID plus ID, this will be solved first, and then you will add it by with ID. So finally, what we are getting from here, ID plus ID plus ID, like this. This means what? Right associative. So plus will become right associative, and here plus will become left associative. So right recursion means right associative, left recursion means left associative. So this is your first disambiguity rule, and lots of questions has been asked in various competitive exam according to this rule only. Don't worry about the questions. When I will jump to the questions, you will get the idea that how exactly questions have been asked and so on. But these are very important points. You have to remember them. Left recursion, left associative; right recursion, right associative. Yeah. So see here, left recursion, left associative; right recursion, right associative. Okay. Yeah. So please try to note it down carefully. Okay, I will see disambiguity rules. So try to note it down till here and then note it down till here. Done? Yeah. Now note it down these things. So first rule we have done left recursion, left associative, right recursion, right associative. Yes. So now let's jump to the next slide now. See, E goes to E plus E, E star E and ID. Is it ambiguous? Yes, obviously it is ambiguous. Take an string W. See, again, same problem. Again, same problem. E goes to E plus E. Or you say E goes to E star E. So again, 2 path. When 2 path, obviously 2 path trees. Okay, so that will create very big problem for us. So hence grammar will be ambiguous. Now let me show you any string. If you want an example, then obviously see, I need not give you example because I have already told you this grammar. See the previous slides. Okay, see the previous slides. See here, yeah, I have already told you 2 plus 3 star 4. We have given 2 passes. Okay, so I'm not repeating this concept again and again. So we have already told you that this is a ambiguous grammar. Now, if we apply our first disambiguity rule, left recursion, left associative, right recursion, right associative. So directly, indirectly, we will stop one path. We will stop this path. We will stop this path. Okay, and we already know plus is left associative, star is also left associative. So we will drop these paths. Okay, so what we will write, grammar will become E goes to E plus ID, E star ID and ID. Now with guarantee, I will say that this grammar is unambiguous. This grammar is ambiguous and this will be unambiguous. With guarantee, I will say. Why? Because we have only one path. But still we have a very big problem in it. What is the problem? See, if we take string as 2 plus 3 star 4, okay, or you take string as 2 star 3 plus 4, see carefully what exactly is going to happen here. 2 plus 3 star 4, answer should be 14. Are you getting answer 14 from here? See carefully. E goes to 2 plus 3 star 4. Now, you will say E plus ID. Okay, sorry. You have to apply E star ID first. And then you will say E plus ID. And this ID, E goes to ID. Okay. And this ID will be 2 and this will be 3 and this will be 4. So you are getting what? To solve this E, you have to solve this E. So 2 plus 3 will be done first and then multiplied by 4. So answer you are getting is 20 here, which is wrong. And here answer should be what? 2 star 3 is 6. 6 plus 4 answer should be 10. See carefully, are you getting answer 10 or not? E goes to E plus ID, E star ID and ID star ID plus ID. So 2 into 3 plus 4. See, I am making pass 3 and please you try at your home. You will not be able to construct any other pass 3. And here also you will not be able to construct any other pass 3 because I have already told you this grammar is unambiguous. So you will be able to construct only one pass 3. That's it. So that pass 3 I am constructing. Yeah. So finally what you are getting is 2 into 3. Okay, see here. To solve this C, you have to solve this. This C will be what? 2 multiplied by 3 will be done first. 6 plus 4, that is 10. You are getting answer 10. So here you are getting correct answer. So finally summary will be what? Whatever operator is coming first, that will be solved first because we have done left recursion. That means what? Left associative. Both plus and star are left associative. And whatever operator is coming first, that will be solved first. That is the biggest problem in this grammar. Okay, so I think you are getting it. So here plus was coming first. See here carefully, plus was coming first. That's why plus was solved first. Here star is coming first. That's why star was solved first. So when plus was solved first, so 2 plus 3, so 5, 5 into 4, 20. That's why we are getting answer 20. Here star is coming first, star will be solved first. 2 into 3, that is 6. 6 plus 4, that is 10. You are getting answer 10. Luckily, this is correct, and obviously this is wrong according to mathematics. I hope I have made the point clear. So what should be done to give precedence? So second rule will be how to give precedence to the operators. And many questions have been asked in GATE as well as NET and various competitive exam. So see here carefully. What can be done to give precedence? See in this pass tree. The operator which is at the lower level, that is solved first. Here also see, this is at the lower level, so it is solved first. So lower level is solved first and upper level is solved later. Are you getting it? See, this is your next rule. Okay, this is your next rule. Second rule. Second rule is saying what? Level is inversely proportional to precedence of operator. More is the precedence, lesser will be the level, or more is the level, lesser will be the precedence. So I hope I have made the point clear. Level will be inversely proportional to precedence. Okay, so lesser is the level, more will be the precedence. Okay, okay, so I think you may get confused here what exactly I am telling. Okay, so let me first brief you something and then I will come to the second rule. Okay, so see, we have got, see here, we have got, finally we have got this grammar na, E plus ID, E star ID and ID. Grammar is unambiguous, but we are not able to assign precedence. To give the precedence, I am saying lower level, more precedence. Lower level means level in the tree. Lower level, see here, lower level, more precedence. Higher level, less precedence. See here, lower level, more precedence, higher level, less precedence. According to the tree, I am saying. Okay, so please don't get confused. According to tree, I am saying. Yeah. Now see here carefully. What can be done? So I directly, indirectly, I want to say that in the tree, in the parse tree, star should be at the lower level and plus should be at the higher level. So this is the standard way. We will say E implies E plus T. T implies T star F and F goes to ID. T. So see, now this grammar is a perfect grammar. And according to precedence, we have written this. See, star is at the lower level, so it will be having more precedence. Plus is at the higher level, so it will be having less precedence. Higher level, lower level, according to parse tree, I'm saying. See, I will construct the parse tree, you will get the idea. Okay. So take that string only. Okay, so I will take the string as ID plus ID star ID. Okay, so according to this, I will say E goes to E plus T and T goes to T star F. E goes to T, T goes to F, F goes to ID. T goes to F, F goes to ID, and F goes to ID. Now see here carefully. To solve this expression, you have to solve this expression and you have to solve this expression. So to solve this, you can say it is term. Okay, so expression can be expression plus term. Term can be term star factor. Factor can be ID. Like this we have written. So E goes to E plus T. So E goes to T, T goes to F, F goes to ID. So this is already solved. To solve T, you have to solve T multiplied by F. So to solve this T, you have got ID and here you have got ID. So let me write different. So 2 plus 3 star 4. So you have written like 2 plus 3 star 4. Okay. So how we will solve? See here carefully. So 2 plus C. First you have to do 3 star 4. Now obviously you have to do 3 star 4 and then you have to add it by with 2. So finally you will get what? 14 as your answer. And you already know answer should be 14. The star is having more precedence because T plus T. Now you have to solve this T first. So 3 star 4 will be done first and then it will be added with 2. Now you just reverse it. Okay, if I say, okay, let me give you another string. Like you say 2 star 3 plus 4. Answer should be what? 10. Again, see here. No doubt plus and star, we were having both operators and star was after plus, but still star was solved first. And here also star is before plus, and but because star is having more precedence, so again star will be solved first. So see here, this grammar will guarantee that. I will say E goes to E star T, sorry, E plus T. E goes to E plus T. Okay, and then this E goes to T. Okay, and then this T goes to T star F. Okay, and This T goes to F and F goes to ID, and this F goes to ID, and then this T goes to F and F goes to ID. If you are not able to follow that, sir, how you are making pass tree, these are very simple. See, we have plus here. Now we have 1 plus. So you have to write E plus T. We cannot write E goes to T and then T goes to T star F. Because once we reach T, you write T star F, then you cannot have plus. Since this, again I'm repeating, this string is having 1 plus, you have to write E plus T one time to get plus. And here, see, we have 1 plus and 1 star. We have 1 plus, huh? That's why you have to write E plus T. So blindly I have written E plus T. There is no confusion at all. I have to write E plus T. Then this E, now you need multiplication. For multiplication, you need T star F. So obviously this E will go to T, T goes to T star F, and so on. You have got the idea now. So 2 into 3 plus 4. So here you should be getting 2, 3, and 4. Now it's obvious. To solve this E, you have to solve this E and this thing. To solve this E, you have to solve this thing. So finally, you have to multiply 2 into 3. Then you will get this E, and add it with 4. You will get the answer here. So finally, you will get 10. So it hardly matters. Star is after plus or star is before plus. Our precedence, we have given successfully precedence to star. That means star is having more precedence than plus. Okay, so now according to past year, I have given you the idea. Okay, so please note it down carefully. Yeah, please note it down these things and these things also. So now see, level is inversely proportional to precedence. That means more is the level, less more is the level, less will be the precedence. Lesser level, more precedence. Okay, so see here carefully. E implies E plus T. Lesser level, sorry, a more level, more precedence. This is lesser level, more precedence. Lesser level, more precedence. So I hope I have made the point clear. Okay, so see, now see, if you are not able to follow it, just leave it. Okay, you just have to see this thing. More close to E now. If close to E is what start symbol now. More close. That means what? Less precedence. If it is far away, then it is having more precedence. Okay, so plus is having less precedence and star is having more precedence. I hope I have made the point clear to all of you. Please note it down carefully. So as soon as see, you may think that I have done on a very faster manner, but don't worry, I will solve lots and lots of questions and you will be definitely comfortable in all these things. These are very basic things. Okay, so on seeing this grammar, you will directly say plus is left associative or right associative. You will directly say, see, E and E, left recursion now, so plus is left associative. Star is left associative or right associative. Star C, T and T, left recursion now, so star is left associative. Plus and star, which is having more precedence. You will say star is having more precedence because star is far away from E, or it is at the lower level. That's why it is having more precedence. Plus is at the higher level. That's why it is having less precedence. I hope I have made the point clear to all of you. So please note it down carefully, and I'm jumping to the next slide, and I will solve some questions. So we have only 2 disambiguity rules. First rule is, see, in the summary, I think I have written in the next slide. Please note it down carefully, and I am jumping to the next slide now. Please note it down this thing and this also. Yeah. See, okay, so I have not written the summary. So let me write it here only. Summary. Summary is, we have 2 rules. First rule is what? Left recursion, left associative, right recursion, right associative. Second, more is the level, precedence is less, and less is the level, precedence is more. According to past P, I am saying. Okay, if you are able to follow it, then it's okay. Otherwise, just see here carefully. Okay, so plus is nearer to E, na? So it is having less precedence, and star is away, so it will be having more precedence. That's it. Okay, this is the summary. Now I am jumping to the question and try to answer that. First question is same to same I have written. So this type of question can be asked, plus and plus. So this is the left plus and this is your right plus. So since this is left associative, now plus is left associative because of left recursion. So I will say left plus will be solved first and right plus will be solved later. That is the basic rule, and such type of question have been asked many times indeed. So plus and plus, which will be solved first? Left plus will be solved first. Star and star. So star is having left recursion, left recursion in case of T here. So star will left star will be solved first. Plus and star. So directly I'm saying that we have plus and then we have star. So according to it, expression can be A plus B star C like this. So which will be solved first? Obviously star will be solved first. And this is saying what? Star is before plus. So A star B plus C. So obviously which will be solved first? Star and plus. Star will be solved first because star is having more precedence than plus now. Because star is at the lower level and plus is at the upper level. So I hope I have made the point clear. Please note it down carefully and I will jump into the next slide. Yeah. So E goes to T plus E, T goes to T star F or F goes to ID. Now see here carefully. This is left and this is right. So see E and E, right recursion. Right recursion means what? Right plus will be solved first. And T implies T star F. So T is what? Left recursion. Left recursion means star will be left associative like this. And star is having lower level, plus is having higher level. See, this is lower level, this is higher level. So star will be having more precedence. This is our final answer. Please note it down carefully and I will jump to the next slide. In GATE exam, they can ask direct question that which is having more precedence, star or plus. You will directly say star is having more precedence. Which is having lower precedence, star or plus. You will say plus is having lower precedence. Which is left associative? Star is left associative. Which is right associative? Plus is right associative. Please do not say sir, according to mathematics, plus should be left associative. We are not doing mathematics. We are doing compiler design. So here, according to this grammar, plus will be right associative and star will be left associative. I am not saying this has been derived from disambiguity rules only. Okay. Yeah. Please note it down and I am jumping to the next slide. Yeah. So now see, T implies E star T or T, T implies T star F or F, T plus F or F, and F goes to ID. So plus, see here plus, left associative, star, left associative. Now plus is at the lower level, star is at the higher level. So obviously plus will be having more precedence than star. Again, I am repeating, this is not mathematics, this is compiler design. So according to level, we have to decide. Plus is at the lower level, so plus will be solved first. If you are having any doubt, then let me clear this for you. See, if I write 2 plus 3 star 4. So what will be done first? See here carefully. E goes to, see, we have 1 plus and 1 star. So obviously, you have to blindly, you have to apply E star T. There is no way out. You have to apply E star T. Now, we need a plus. So E goes to T and T goes to T plus F. Okay. And this T goes to F and F goes to ID. This F goes to ID. T goes to F and this F goes to ID. So see here carefully. So 2 plus 3 star 4 now. 2, 3, 4. So obviously to solve this E, you have to solve this E. And when you are solving this E, directly and directly what you are doing 2 plus 3. That is 5. So 5 multiplied by 4, that is 20. Answer will be 20. So directly and directly 2 plus 3 is done first, then you have multiplied by 4. So I hope I have made the point clear to all of you. Okay, please note it down carefully and I am jumping to the next slide now. Yeah. See the next question. E implies T minus E or T. T implies T plus F or F. F goes to F star G or G. G goes to ID. Again, so now we have 3 operators. Okay, so plus and plus. See, plus is left associative now. See, left recursion, left associative, like this. Minus is what? Right associative, na? Right recursion, so right associative, like this. Star is what? Left associative. Plus and star, which is having more precedence. See, plus is at the star is at the lower level, plus is at the upper level. So star is at the lower level, na? Star is having more precedence. Star and minus. Star is at the lower level, minus is at the upper level, so star is having more precedence. Plus and minus. See, plus is at the lower level, minus is at the upper level. Plus is at the lower level, na? So plus is having more precedence than minus. Again, I am repeating, this is not according to mathematics, this is compiler design.
Okay, please note it down carefully. And I am jumping to the next slide now. Okay. Yeah, this is very good question. This has been asked in GATE exam. Okay, so that nobody can cheat and nobody can do mathematics and so on. So please make some star on it. Okay, this is a GATE question. So now you do not know what exactly is dollar. You do not know what exactly is at the rate, and this is what. Okay, so we do not know all these things. So we have three operators. So now just tell me, dollar is what? See, dollar and dollar. Dollar is what? Left associative or right associative? See, left recursion, so left associative. At the rate, left recursion, so left associative. This is power operator. Okay, so power operator is what? Right recursion. See here, F and F, right recursion, so right associative, like this. Dollar and at the rate, which is having more precedence? At the rate is having more precedence than dollar. Dollar and power, which is having more precedence? Power is having more precedence than at the rate. And dollar and power, power is having more precedence than dollar. So question can be asked, which is having least precedence? Least precedence dollar. Which is having highest precedence? Power. Which is left associative? All are left associative. Sorry, dollar and at the rate are left associative. Which are right associative? Power is right associative. And so on. Lots and lots of questions can be asked from this single grammar only. So I have made the point clear to all of you. Please pause the video, note all these things, and whatever question I have said here, please pause the video and note them also. Okay. Yes, I am jumping to the next slide. Now see, this is a very good question. This is also a GATE question. Okay, I think it was it came in UGC-NET also and GATE also. UGC-NET exam and GATE exam also. Yeah. So see here carefully. So now star and plus, which is having more precedence? Obviously, both are at the same level. So star and plus both will be having equal precedence. So star is left associative. Yes, star is left associative. Plus is also left associative. So whichever comes first, that will be solved first. So ID plus ID star ID and ID star ID plus ID. So this will be solved like ID plus ID star ID, like this. And this will be solved like ID star ID plus ID, like this. I hope I have made the point clear. And what about my minus? I cannot assign any associativity to minus because F goes to F minus F, this also and this also. Grammar is ambiguous. So I cannot say a minus is left associative or right associative. Okay, according to past tree, we can design a past tree according to expression, and we can make it left associative also, right associative also. Okay, so we cannot assign any associativity to minus. Yes, but one thing is sure, minus is having more precedence than star, and minus is having more precedence than plus, because minus is at the lower level. Okay, so I hope I have made the point clear. Please note it down carefully, and I'm jumping to next slide. Yeah. So next category of grammars is see, we have already done contextual grammars are of two types, ambiguous and unambiguous, and now we are doing next categorization, that is left recursive and right recursive. Okay, and I think we should do this thing in the next class because this class is getting a bit longer. Okay, so let me stop it here only, and we will start next class from this topic only. Okay, thank you so much. Bye bye.